The next thing is ectoparasites. I just use here our amblyomma as an example. But we can get abscesses that can be on the outside if we're lucky, and we can launch them and maybe not major damage to the udder, but sometimes they can break open to the inside of the parenchyma where we can then lose the udder. Things like thorns in bushy areas can play also a major role. So make sure that you look at any lesions, any ectoparasites, identify them and get rid of them on the udder. Another thing that we can see that is part of the environment, if we look at the left-hand side, we see staph impetigo. This is we see that mainly in the older animals, and we think that exposure to the sun has played a role here, making the skin more vulnerable. And in most of these little lesions that you see here, if you can open them up in a sterile manner and take a swab from them, you would isolate Staph aureus. On the right-hand side, necrotic dermatitis. This happens because the animals are in a wet environment, and very often because the front quarters are very close together, the area there remain moist and lesions can develop, huge lesions can develop there. The problem why they exist is most of the time nor the farmer nor the milker can see the cow because or see this lesion, because the cow is most of the time standing with her back part or the side towards the milker. Then we can consider diseases, and I've just got one or two here. Zoonosis, and Prof, I think this is your picture, thank you. Reverse zoonosis, where the cows can actually, with agalactae, cause milkers nodules on the milkers. And I've spoken to you in class already. We had in 2000, basically the year 2000, we isolated more human Staph aureus from milk of dairy cattle than the dairy cow or the cow strain of human aureus. The cow strain of aureus. We have now, through genetic analysis, proven that it is actually so. So that is a problem in our country, especially we know about it. We have to take care and make sure we as people don't infect the animals. So I'm not going to put a lot of emphasis on here, but I do want to look at the main agents that cause mastitis in South Africa that is mainly originating from the environment. Escherichia coli, not so much in numbers, but we will see, and hopefully you know by now, it can be a very, very severe disease. Klebsiella species, we do not see a lot of them yet in South Africa, but in certain states of America, they are play a major role. I know Wisconsin is one of the places that they really struggle with Klebsiella. Serratia is something we see from time to time, not a major problem, but we need to be aware of it. And the main thing with Serratia is in our quick methods of identifying gram-negatives, we need to distinguish Serratia, Klebsiella, and E. coli to be able to know what the next step is. Excuse me a second here. The upcoming problem in South Africa, Streptococcus tuberous, you know, that's a problem in New Zealand. We'll look shortly at that. And then Discalactae, although it is now more classified as a contagious agent, or it was classified as a contagious agent, it's now more believed to be also connected to the environment. Now, this is important to remember. If we look at contagious organisms and the environmental, usually the contagious ones, once they infect, is a long duration of intramammary infection. Not all environmentals are short, but they on average shorter duration. We get higher cell count in the contagious one, and initially low cell count in the cows infected with the environmental one. But here's the important one coming up now. The high somatic cell count in contagious ones, we can see a while before the clinical case happens. Now, we spoke about new technology. There are new technology now with the Delaval or the Delpra, Ultra, and Affimilk system that can detect this early changes, and they can basically warn the farmer, watch out, this cow may get mastitis. The problem is if we look at the environmental ones, that doesn't happen. We have a low cell count, and then the next moment usually we've got that severe clinical cases. So at least for the contagious, we might have in future an earlier warning system. If we look at days in milk, usually contagious increase as the cow are longer in lactation, whereas with the environmental, it's more a question of the cow is more, the immunity is less effective, and that happens more just postpartum, first 100 days of lactation. And yeah, the incidence is not related to the prevalence in the case of environmental mastitis, where it is in contagious. Right, so just overall, again, I just mentioned the problems we had, but the source of this infection is the soil. And bedding, very often, remember, we've got animals in freestall barns as well. Overseas, bedding plays a huge role because those animals are kept indoors for 7, 8 months or even longer during the year. It is excreted in the manure, so wherever manure is, it is, and then it can be in the water. So that is why we try and make very sure that the drink water we have in town doesn't contain it. But safe to say for you, it's not always the case. All right, the low somatic cell counts hurt. So our farmers that improve their management to a very, very high level, those are the cows that are more vulnerable. And these, the problem with the coliforms is most of them, as you can see here, end up in clinical mastitis, where, for instance, even our aureus, but our cogla is negative or non-aureus staphylococci, a large percentage of them doesn't become clinical. They subclinical, drain the cow, but the farmer doesn't know about it because it's subclinical. The coliforms plays the different role. And then on the ones we can see that's a clinical, you can see, looking at the picture, a very acute or per-acute situation. Now, important here, if we look at if there's infection of the coliforms, the colony, in other words, the number of bacteria that start multiplying, reaches the peak from 5 to 16 hours. So you can imagine a cow being milked that morning, infected with via manure with E. coli. 5 hours later, she is on the peak of that number of bacteria, and when she comes in for milking at night, that cow can have a severe per-acute mastitis and want to die. All right, only after it reached the peak or stimulated with the peak, we get a reaction on the neutrophil migration, and only after that we get a reaction with phagocytosis and killing. But very often this might be too late, where the endotoxin has already been released. Now this is just showing you an indication of an E. coli. Those of you who've been in class, I showed you there the Staph aureus that ran for its life. The eco sits like a blob, and so if we can have the macrophages and things there, they can sort it out. But we need to have the cow on a way that she is actually ready for that infection. Maybe before we look at this, some of the research we did in early years is we placed a piece of plastic inside the teat cistern, that it bops up and down there. And the whole idea was to irritate so that we have constantly at the bottom where the bacteria, the new bacteria can enter a high somatic cell count. This worked very, very well. The rest of the milk didn't have our cell count. We had very high cell count, so if any bacteria entered, there were immediately a high number of cells to cope with it. And the only problem was, in about a month or two's time, milkstone was deposited on this, and it was no longer a foreign irritating body in the teat canal or in the teat system. So you can understand the principle, but we couldn't get it working. All right, now the next thing, somatic cell count, is most of the time used as an indicator, but remember, for the farmer, it is costing him money. So if we look at the normal, if you look horizontally, that would be the blue line going right through with a low somatic cell count. If we look then at the second graph, which is the E. coli going up, normally it goes up to the very high cell count and then it comes down. And you can see this is in days. It can take from start 10 days plus with still very high counts, even if it's not a period situation where we cannot use the milk really in the bulk tank. If you look at aureus, it's the blue line. You could see it goes up, it remains high, because most of the time this will become a chronic infection. And then hubris, our new kid on the block that is going to give us some challenges in the future, it comes up and you can see it remains with a very high cell count. E. coli can sometimes, if you look here, this is hours after the challenge. You can see this is a linear score that is used here, but you can see the cell count also here remains even at 100 hours. In this case, it was still high. And what additionally happens, the green line that you see there is the standard plate count or bacterial count that also goes up because of the increased number of bacteria in the milk tank. If we look at milk loss profiles, we all of them look at the same time period. You can see E. coli, because it can cause such a severe mastitis. We've got a huge loss in milk production and it struggles to go up. Compared with aureus, where the individual, when we get mastitis, the loss per mastitis event is maybe less, but that remains over a period of time. And the similar situation is then seen for hubris. And obviously we are looking at the moment, there are ones that are chronic and ones not chronic. Now, if we look at E. coli, this is a photo of, sadly, I have to say, at our proof blast. You can see the quarter of the skull became totally necrotic, the bottom part of it, due to that endotoxin. This was removed surgically, and this is what the cow looked after about a week or so. She has healed now, but obviously you can see the damage done by E. coli is extensive. If we move to Klebsiella, I said to you earlier, we haven't got a lot of that yet, but we should be aware of it because the overall losses of Klebsiella is much higher than E. coli. It also tends to be much more of a chronic infection, and the treatment of that, the response is very poor. The damage to the udder is high, so the production loss is very high. So a large part of these animals eventually will be slaughtered. This is just a case study I got from one of our colleagues in Wisconsin, or Cornell University at the moment, using the udder hygiene score. You can see there at the top, the 1 and 2 is the score 1 and 2. They are below 30% of the area dirty, and the score of 3 and 4 is more than 30%. So what has happened in this herd is they've done the cleanliness score and compared it then with the Klebsiella positive cases. And you can see in the first example, before they do any other preparation, there was not a very good correlation between the udder gene score and the Klebsiella. Actually, the dirtiest udders seem to be the best off. But once they implemented pre-dipping, they implemented making sure that the udder is clean, that's being milked. You could see in the two herds, that's the black and the white, it's two different herds. You could see the picture change quite a bit. And then there was a better correlation between Klebsiella positive animals and the udder hygiene score. The score, as I told those of you that we've been at the call again, is a very, very practical method of identifying the risk of environment. We do it on the udder, on the flank, that gives the idea of the bedding where the animal is lying down, and then on the feet where the animal is walking. So very practical things for me to use in the field. If we move then further to our streptococcus, Discalactae is at the moment not a big role, but I know in some of the European countries, and I know for a fact in Israel, this is starting to become a big problem. They're also very difficult to treat and get rid of. With your Streptococcus hubris, for instance, you only see 40 to 50%, and in our cases, we've seen less that actually show clinical signs. So this is always a problem that the farmer won't be aware of this problem. And there, again, it's so important to do microbiology to make sure what is going on in this herds. It's the most common one isolated. It is most common also during the dry period, not only in lactation. It can be responsible. Remember earlier on when we had that table where we looked at the yes-no option, you sometimes get a spike. If it's very wet outside and the animals are on pasture, you might get a spike in the bulk tank once off. Be sure to look at then at the hubris. And as we're learning more and more now, and we're busy with research currently, we're finding that more, and especially in South Africa too, of the Streptococcus hubris is becoming chronic. This is just an example of a herd that's regularly sent in samples. It's on pasture. It makes use of manure, dry manure that is spread now for the last 20 years on the area where the animals are grazing. And what we're starting to see here now, you can see that 11170 is one cow. She tested positive in March, April, June, and in October. And if you look at the somatic cell count, you can see in all of these cases, they're above 2 million, 3 million. If you look at the bottom of the page, the other one I marked for you, we see very, very high cell counts from time to time. There's a 17 million with hubris. I have lately seen one of 35 million somatic cell count. The problem here compared with Agalactae, where we also see this very, very high scores, is Agalactae is in the lactiferous ducts, and it's not necessarily an indication of other damage. The problem with hubris is it is the same as aureus, also an intracellular organism. So this might be, and we'll learn more about that hopefully in the year to come, also indication of probable damage to the udder. Now I've just thrown in one or two other bacteria. If we think about Pseudomonas, we mainly think about fresh water. I've encountered Pseudomonas outbreaks, I think in my whole career I've seen 4 or 5 of them. But the thing is, the moment you find this outbreak in udder health problems in a herd, it's a major catastrophe. What is important here, it is usually in fresh water. You can see troughs, sprinklers, ponds. A little bit down, I've written It's found in absolutely pure water. It doesn't need to be water that has a lot of organic material. They can survive in crystal clear water. Basically on the soil, on plants. If you have Pseudomonas and you would wash your tomatoes and potatoes and whatever, it can also be on them if you irrigate them. It can survive almost in anything. Swimming pools, hot tubs, air conditioner, even in jet fuel. So it is a very, very, very tough organism to deal with. Maybe just a little bit practicality of it. If there is a high concentration to which the dairy cows are exposed in the parlour, you usually see an acute infection that can follow by death. If there is a low grade of exposure, it is usually a chronic infection where the animal has been for a long time and basically we can't get rid of it. The additional problem with chronic infections is if the Pseudomonas come into the rubber parts. Enriquez asked earlier about rubber versus silicone. Silicone is much better here. But if it comes into the rubber parts of the milking machine, the only way we can get rid of it is basically by chucking away all that rubber parts. We can't get it out of there. We had once a case where there was in the water Pseudomonas, the drying off remedy was put into in the parlour in a large container, and it was pulled up and down as the animals were dried up. So they just used from that large container. And what happened, the water contaminated the outside of the intramammary preparation, and the hygiene with application was not good. And shortly after application, I think that was about 12 animals that was treated, 10 of them died. So really it's a disease that we really want to try and avoid. Another one that's maybe of importance is Listeria, also available in the soil, the water, definitely in feces. But we mainly think about it when we look at dairy cows in the silage. It can survive there for quite a long time. And it can survive in high salt environment, acid environment. Refrigeration doesn't bug it, but we're lucky that it is killed by pasteurization. If we think about the rumens, we can get it as mastitis, where it can cause chronic mastitis. We often, when we do isolate it from the bulk tank, we have to do two things. We first of all have to sample the animals to make sure or not whether the bacteria actually are coming from the cows, because what we often find is that when especially your silage is close to where the bulk tank is, or trucks are driving past with the silage past the bulk tank area, that contaminant from the silage can actually go into the milk and contaminate it. And obviously this is not something we want in our milk. None of us want to drink that. So just a little bit about how do we tackle this. I believe the future is really avoiding diseases rather than treating it. Optimize the management against our nutrition and hygiene. We've been over that. Vaccination can be a great way, good vaccine. Monitoring, that we know where we are we going, and then integrating disease programs, not just working on one, but on different ones at the same time. So again, milking routine, and I know the students might be fed up with that, but it remains the foundation. If that basis is not sound, you can do all the fancy tricks in the book, but you will not be able to have sound udder health in a herd. Dry cow therapy, that is extremely important, and I'm going to talk a little bit less about it because I see there's a lecture later by Zoetis. The only thing I want to leave with you and for you to think about is, I know we're in the era where we have to. think very much about the way we use antibiotic and use it prudently. But prudently means not using no antibiotic. Means using the antibiotic in an effective way without creating any resistance. Now, we know from other health that during the dry period, we have double success in treatment. And we know that most of the new infections occur just after drying up and just before calving, when the teat canal is under a lot of pressure to open and the bacteria can move in and out. So we know the dry period, we need to look at the treatment will be both for killing the bacteria that's in a subclinical format in the udder and preventing new infections. And we've spoken about internal teat seals. The way we can do this in a sound way is where animals has got an infection, treat them with antibiotic plus a sealant if there's a huge risk in the environment. If the cow doesn't have bacteria, only treat her with the internal sealant that we've got on the market, but very, very hygienically. The way to make this decision would be, and we've got quite a few farmers doing this already, they are sending us the samples about 2 weeks prior to drying off, because our large farmers are doing it in a big group. We do microbiology on this, and then they can make a sound decision on whether or not to use bacterial therapy. And I think that is the way forward to the future. We can cut in the antimicrobial use, but we can do it in a prudent manner, not creating resistance and not putting our animals at high risk for new infections. This is basically what we said. This is just in a graph format where your risk of new infections is so much higher. Now this again is a photo I borrowed from Prof. Tina van Werden from Utrecht. This is what they marketed, the time period, how you have to look after your cattle, dry cow and lactating cow. Remember, they had to cut the use of antibiotics by 70% in a question of 6 years. And they did it. And they not only did it, but their other health improved. So I think we need to learn from the example as well. It is just we need to look at the barns when the animals are on the dry, avoid overcrowding. Make sure the ventilation is good. If we look at pasture, the same story is overgrazing, overstocking. Ensuring shade is, yeah, it's more than we're able to do in our country, but we should try to have products that's at least well drained and manage the troughs, that we don't have troughs overflowing. And very important part of our hygienic environment is the area where the cows are calving, to keep that as clean and dry as possible. If you look at the vaccine that we can use as a preventative measure, we don't have a lot. We have basically the StartVac that caters for the Staphylococcus aureus, both the non-aureus staphylococci, or the old coagulase negative stuff, and aureus, and on the other side then for your coliforms and your E. coli. We've been over the injection, but in essence for E. coli, and we've got the E. coli from Zoetis also, which also includes the coliforms. With there, we have to target the animals' early lactation because they are the most vulnerable group in the high-risk period time. For Staph aureus, we basically have to target right throughout lactation. And from my point of view, the animals that are infected, to lower the shedding, and then the most vulnerable animals in the herd. I'm very hopeful. I only know that the strep uterus vaccine has been submitted to Act 36 for registration, so we are holding funds that we might have this vaccine on the market in due time. just something to remember when vaccinating the udder. When vaccinating, we basically get the immune response. The antibodies are circulating in the bloodstream, but the blood udder barrier, not many of them passes through there. It is only in a situation where we get inflammation, where the blood udder barrier becomes much easier for that immune system to get right to the polymorpholeucocytes and neutrophils, to get right down to the udder and work. So with vaccination, we cannot expect a major prevention, but we can expect a lot less clinical signs, lots less shedding time, and it's actually a tool to help us to manage the situation much better during the crisis situation. One of the things I just added here, excuse me, because Uberus is upcoming, we're not only looking at how can we try and basically help the cow from getting it, looking at a first and second line of immune system, trying to not use manure and the slurry on the fields, but because it is such a cost-saving aspect, I believe in future it will be used more and more. So the other aspect will be looking at slurry and seeing how we can utilize it and actually make it less, that not so many of this hubris can survive, and that we can use it effectively on the pastures. Now, if we think about the old way that manure was kept, it was kept in a huge heap. When it was in a heap and you would open it up and feel the temperature could go up to 70 degrees centigrade. And this effect killed actually a lot of bacteria. So in the old days, it was not such a big problem as it is now, because your modern slurry tanks actually keep it oxygen free and keep it cold to prevent the loss of nitrogen. We want as much nitrogen to put on the fields, and that is why so many of the bacteria actually survive. Now, things like biogas plants, the anaerobic fermentation process, in which the waste of is digested by the microbes to produce methane. Some farmers are using it in the form of deep anaerobic dams, but obviously the gases that can come from that can be harmful and not smell as good. This is maybe another solution. Putting a tank basically on a cow and utilizing the gas and then using that methane gas to go and have a braai. I don't think, however, it will be a long-term solution. But the effect of inactivating uterus is one of the things we surely must look at in future in preventing that bacteria from growing. So to conclude, there is a huge variation within the species, how bacteria is transmitted in the environment. We saw now it is mainly the soil, it can be the water, but it can even be in the environment, in the air itself. So the health of the animal is first of all determined by the risk, and this is all the above. So the risk to new infections, the duration of these infections, because the longer the infection, the more the shedding will be, and then the transmission risk, will it be in the parlor, will it be in the area where the animals are. So, and remember on the cow side is whether or not she can handle that risk. Teat canal, secondary immune system. This I found, if you ever have the opportunity to go to Afimilk in one of the offices as you walk in, this is what stood there, and it really showed you where we are maybe moving away from, not caring about the animal, that it just becomes a tool in getting money, getting milk. And I think at the end of the day, we should still admire this animal for what she is, the incredible amount of energy she puts into the milk and the output. And we should really look after them well, because if the farmers can look after these animals well, they will look after them well. Thank you very much.